Hello, this is Dr. Michael Wu. I'm the Chief AI Strategist at Pros. So ever since we formed the COVID-19 Taskforce to help our customer navigate this pandemic, many of you have asked, what are we doing with the valuable data that you share with us? So today I'm going to try to address this for both our airline customers as well as the B2B customers.
So for airline, we get their booking data, which is a time series of all the origin destination they cover and fare compartments. And we also have epidemics, which is also tracked as a time series of confirmed cases at the country level. And really what we're trying to understand is that we're trying to see how does this epidemic impact the booking. And so if we believe this is the direction of causality, then if we were to observe some changes in booking at time t, then it's probably caused by some changes in the epidemic at an earlier time t minus tau. So the way we solve this problem is we solve it in two steps. First is we have to estimate this characteristic lag, tau e, right here. And this can be solved easily by constructing the cross-correlation function between this two-time series. And this cross-correlation function is really easy to understand, even though it has an integral in it. But really what it means is that if there was some feature in the first time series, right, and at time t, and that same feature happened at a later time t plus tau, then this sum is going to be large. So this is cross-correlation function is a function of lag, of all the different lags they have, right? To find this optimal lag, basically we're trying to find the peak of this cross-correlation function. Okay, so that's really just a simple optimization problem. Now, once we find this lag, we can answer the next question of how big is this impact. Okay, so the first step actually gives us how long does it take some changes in epidemic to trickle down to some changes in booking. So the second step actually answers the question of how big is this effect. So this we can actually solve by setting up a regression problem between the epidemic and booking, right? So this is a linear regression, and we have to shift this time series with the characteristic lag because we are treating each time sample as an observation in the standard regression problem. Otherwise, this regression coefficient will be pretty small. Okay, so once we set up this regression, then we could do this for all the flights from a country or into a country. Now, this is a very simple linear regression, and we can actually capture some of the nonlinear effect if we actually transform these the epidemic data into some feature space with the feature map F. Now, the important components of this feature map F can serve as an early indicator for booking recovery. And this importance is actually determined by how big and how important this coefficient is. Now, if we were to do this cross-correlation directly between the epidemic data and the booking, we are likely to get a very, very broad peak. And the reason is because there's actually many things that could have happened between the changes in epidemic and the changes in booking. So what we really want is a tighter chain of causality, okay? So for this, we need to ask ourselves, what is a more immediate cause to some changes in booking? So we can hypothesize several different hypotheses. First is that it is probably because of there's some changes in shopping. If we want a tight chain of causality, then we will have to ask ourselves, what would cause a change in consumers' airline shopping behavior? That's probably due to the fact that maybe the government have lifted some lockdowns within a certain country, then people will start thinking about traveling. And what would cause a government to lift a lockdown? Then that's probably due to the changes, ease up of the epidemic itself. So this is will give us a tighter chain of causality. And now you can see why, if we do this cross-correlation directly with epidemic and booking, we'll get a very broad peak, because each one of these processes actually have their own characteristic lag, and some of them actually add up and some of them actually cancel each other out, and we get a very flat and broad peak. So now, as a sanity check, we could actually compute the cross-correlation between the government response and booking. We could do this for domestic flights for O&Ds within a certain country. So if we do this, what we see is that the cross-correlation indeed gives us some very broad peak as what we expected. So the stringency is actually it's a measure of how stringent the government is responding to this COVID-19 pandemic. And this composed of various indices. And one of the indices is government's response by restricting domestic travel. If we do this cross-correlation with that particular index, since we're considering domestic flights only, right, we actually get a very similar kind of a curve, right, very broad peak. But the interesting thing is that like both of these have a peak, somewhere between 3 to 10 days. So we can basically say that this characteristic lag between the government response and the booking is somewhere between 3 to 10 days, right? So we can say that when government lifts the lockdown, it's probably would take somewhere between 3 to 10 days for it to trickle down to changes in booking. Okay, so now what about our B2B customers? So for B2B customers, we can still use these government response and epidemic data as predictors, but we don't have bookings for B2B customers. Instead, we have some kind of signal for demand, right? And these demand signal could be revenue or volume or frequency of purchase. We don't actually have shopping data for our B2B customers either, but instead we can actually try to see what other industries' demand could serve as an early indicator or predictor for changes in a particular customer's demand, okay? So we could potentially use the airline or other industries' demand as predictors. Okay, so for B2B customer, we also need to estimate this lag and the impact of COVID. But one thing that's really interesting for our B2B customers is that, like, unlike the airline customers, which is basically all have been negatively impacted by COVID, some of our B2B customers may be positively impacted by COVID in certain parts of their business. Maybe certain customer or certain product, the demand actually increased. So we will have to look at their transaction table, right? And the transaction table obviously have a date in it. We can use that to kind of split the data up into a pre-lockdown phase and a post-lockdown phase, right? And this transaction table also has information on which customer bought what product, right? And it also has information about quantity, price, as well as lots of other attributes as well, right? And the important thing is that we can also derive this demand signal here, right? So the demand signal is basically either revenue, volume of purchase, or frequency of purchase. So now we need to basically look at a couple of things first. We need to see whether there is a change in demand when you group by customer. So are there our customer who had increased their demand due to COVID? Most of the time will be decreased, but are there some pockets of some customer who actually increased the demand, right? And we can also look at a change in demand group by product, right? Are there some product that's actually more heavily demanded, okay, due to the lockdown? So these will give us a way to create some attributes that would actually help them segment their customer better after the lockdown. So hopefully this will give you a sense of what we're doing, and we are constantly evaluating other third-party data as well. So they will give us a tighter chain of causality. We can have sharper peaks in our cross-correlation and this estimation of this lag, and we would be able to estimate the impact of COVID each step along the way. So that gives us a longer lead time so that we could tell our participants in this study what to prepare for and how to prepare for them. Thank you very much.